Generative AI and machine learning have rapidly transformed how organizations operate, innovate, and serve customers, but they have also introduced new dimensions of risk that now fall squarely within the scope of SOC 2. In this context, AI and ML services are considered part of the system if they process, generate, or influence data that impacts trust, confidentiality, or availability. SOC 2 compliance for AI systems centers on transparency, accountability, and auditability. This means understanding what data is used to train and operate models, how outputs are generated, and how governance integrates with control criteria, such as CC6, logical access, CC7, system operations, and the privacy category. The purpose is not to restrict innovation, but to ensure it proceeds within a structured, ethical, and evidence-backed assurance framework. The first step toward responsible AI governance is maintaining a complete and accurate inventory of all AI and ML components across the organization. This includes cataloging every AI-enabled feature, embedded model, or third-party API, along with its provider and subservice dependencies. Each entry should capture the model's intended purpose, the data sources it draws from, and its retention schedule. Retraining or model updates must be logged, as even minor parameter changes can alter outcomes or risk profiles. By maintaining a structured inventory, organizations can demonstrate traceability and accountability, ensuring no unmonitored or shadow AI processes escape oversight, a critical expectation in SOC 2 and privacy audits alike. Handling data responsibly within AI workflows is central to preserving confidentiality. Sensitive information should be excluded or masked before ingestion into training datasets or inference prompts. Data anonymization and pseudonymization techniques reduce privacy risks while maintaining analytic value. All inputs should be logged and linked to their origin for traceability, with clear procedures for deletion upon request. Encryption safeguards must apply throughout, both in transit and at rest, ensuring that model inputs, outputs, and training data remain protected. These practices directly support SOC 2's confidentiality and privacy principles, ensuring that data used in AI operations is handled with the same rigor as any other sensitive information in scope. Model integrity depends on version control and transparent documentation. Each AI or ML model should have a repository that records its versions, hyperparameters, and associated code artifacts. Signing and hashing model binaries prevents tampering and allows auditors to verify that the deployed model matches the approved version. Retraining events, validation results, and approval checkpoints should all be documented, creating an evidence trail that demonstrates oversight throughout the model lifecycle. Linking these records to change management tickets further integrates AI oversight into existing SOC 2 frameworks. This combination of technical and procedural control ensures both reproducibility and accountability, a cornerstone of trustworthy AI governance. Bias and ethical risk management elevate AI from mere compliance to responsible practice. Models can unintentionally amplify social or data bias if training datasets are unbalanced or insufficiently diverse. Defining bias detection metrics and setting a review cadence ensures ongoing fairness assessments. Fairness testing, ideally performed during both training and deployment, measures whether outputs treat demographic groups equitably. Any ethical concerns identified should escalate through formal governance channels for evaluation and mitigation. Documenting and retaining these results not only satisfies audit evidence requirements, but also signals a strong commitment to ethical accountability, aligning operational integrity with the organization's broader trust commitments. AI provider due diligence is an extension of third-party risk management. Organizations must evaluate their AI vendors with the same rigor applied to other subservice providers. This includes reviewing each provider's SOC 2, ISO 42001, or equivalent assurance report, verifying that privacy, confidentiality, and availability are covered. Shared responsibility matrices should define who manages which aspects of AI safety, data protection, and compliance. Renewal tracking and bridge letter requests ensure continuous assurance between audit periods. These efforts demonstrate that the organization not only manages its own AI risk, but also enforces governance expectations throughout its supply chain, a critical aspect of SOC 2 oversight. Access control and logging are foundational to maintaining AI system security. API keys and credentials for AI models or third-party services must be tightly restricted to authorized users or applications. Every interaction with a model training sessions, prompts, or inference queries should be logged with timestamps and user identifiers. Anomalies such as excessive data exposure or repeated unauthorized access attempts must trigger automatic alerts. Preserving these logs for auditor sampling ensures transparency into how AI systems are accessed and monitored. Access governance over AI resources ties directly to CC6 controls, proving that the same identity and access management rigor applies in machine learning environments. Governance over prompts and model outputs is a uniquely modern control challenge. Prompts submitted to generative AI systems must be filtered to prevent inclusion of confidential, personal, or regulated data. Similarly, outputs require review mechanisms to detect policy violations, biased results, or unintended disclosures. For sensitive workflows, such as customer communications or decision automation, a human-in-the-loop process provides an added safeguard before outputs are published or used. Capturing audit evidence from these reviews, including approval logs or flagged incidents, provides verifiable proof of operational oversight. These controls ensure that creativity and automation never outpace compliance or ethical responsibility. Data retention and deletion policies must extend to AI training and inference data. Retention schedules define how long data and derived embeddings remain stored before secure deletion. Automated scripts should enforce these timelines, logging each deletion event with verification status. Periodic cross-checks between deletion logs and data repositories confirm accuracy. Transparency is critical. Retention practices must be disclosed in privacy notices and customer agreements. By enforcing disciplined data lifecycle management, organizations uphold both privacy commitments and SOC 2 availability and confidentiality requirements, ensuring data does not persist beyond legitimate purpose or consent. Finally, before deploying any AI or ML system, organizations should conduct privacy impact assessments, PIAs, or AI-specific risk assessments. These evaluations confirm that the use of personal or customer data has a lawful basis and that any processing complies with relevant privacy regulations. Vendor compliance with regional laws, such as GDPR or emerging AI acts, should also be validated. Documentation of these assessments becomes a key audit artifact, proving that potential risks were identified and mitigated proactively. Embedding these reviews into pre-deployment processes shows auditors that governance over AI is systematic, not reactive, a fundamental principle of mature SOC 2 programs. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Integrating AI into incident management processes ensures that misuse, malfunction, or model drift is treated with the same seriousness as any other operational disruption. Incidents may include model hallucination that leads to misinformation, unauthorized data exposure through prompts, or failures in output accuracy. Each of these must be logged, categorized, and resolved following the standard incident response playbook. Root cause analysis, RCA, should capture both technical causes, such as flawed data pre-processing, and governance factors, such as inadequate human oversight. Mitigation actions, retraining records, and revised safeguards should all tie back to the risk register for traceability. This alignment confirms to auditors that AI risks are managed through the same disciplined, evidence-backed processes that define the organization's SOC 2 compliance posture. Testing and validation of AI models generate one of the richest forms of SOC 2 evidence. Every model should undergo structured testing to confirm accuracy, robustness, and ethical soundness before deployment. Performance benchmarks, precision, recall, false positive rate quantify reliability, while fairness and bias testing confirm compliance with ethical commitments. Validation checklists signed by responsible reviewers demonstrate accountability for each model release. Storing these artifacts by model ID and date creates a clear lineage for auditors to follow, ensuring each deployed version is tied to a documented validation cycle. This evidence transforms AI reliability and fairness into measurable, repeatable assurance practices. Ongoing monitoring and drift detection safeguard against model degradation over time. Models may perform well during initial testing, but decline as real-world data patterns evolve, a phenomenon known as concept drift. Continuous tracking of accuracy, precision, and prediction variance helps detect such degradation early. Automated alerts can notify data scientists when retraining thresholds are reached, triggering validation workflows and governance reviews. Recording model performance metrics and retraining events provides an operational evidence trail. In SOC 2 terms, this continuous monitoring proves that availability and reliability controls extend beyond infrastructure. They include the integrity of the algorithms that power decision-making. Security and privacy safeguards for AI systems must be as rigorous as for any other in-scope application. All API communications should be encrypted, and model credentials stored securely in vaults or key management systems. Prompt and inference logs containing sensitive data must be either masked or omitted entirely from persistent storage. Environments used for training should remain isolated from those used for inference to prevent data leakage or contamination. These configurations directly address CC6 logical access and CC7 system operations, confirming that AI systems are subject to the same defense-in-depth philosophy governing the broader SOC 2 environment. Protecting AI data pathways preserves trust not only in compliance but in the technology itself. AI governance requires structured oversight to ensure alignment with ethical and regulatory expectations. Establishing an AI risk committee or equivalent body provides a forum for discussing model performance, risk findings, and upcoming regulatory changes. This committee should publish an AI use policy defining acceptable use, prohibitions, and review requirements for all AI applications. Periodic audits and compliance checks validate adherence, while results are reported to leadership and, where required, to regulators. Documenting these proceedings demonstrates accountability and transparency, fulfilling the SOC 2 principle that management must actively oversee all systems affecting trust commitments. Regulatory alignment is becoming a defining feature of responsible AI operations. With frameworks like the EU AI Act, NIST AI Risk Management Framework, and OECD AI principles, organizations face growing expectations for transparency and human oversight. Monitoring these developments ensures policies remain current and legally compliant. Control mappings should link AI governance practices to specific requirements, such as documentation transparency, human review, or risk classification. Gaps must be identified and addressed through tracked remediation plans. Version-controlled policy documentation provides the audit trail auditors need to confirm that the organization maintains awareness of and adherence to evolving AI regulations worldwide. Cross-framework synergy amplifies the value of AI governance by linking SOC 2 controls with other recognized standards. Privacy controls from SOC 2 can integrate with ISO 27701's data protection framework, while ethical and transparency requirements align naturally with ISO 42001 and the NIST AI RMF. Evidence collected for SOC 2, such as bias testing reports, governance minutes, and DPIAs, can often be reused to demonstrate compliance with multiple frameworks. This harmonization demonstrates consistency across assurance domains, proving that AI operations are not siloed, but part of a unified, responsible governance system designed for accountability, fairness, and transparency. Automation and tooling serve as the operational backbone for sustainable AI compliance. Machine learning operations, MOps, pipelines can embed compliance checks directly into deployment workflows, preventing unvalidated models from reaching production. Metadata tagging for models and datasets ensures traceability across training and inference environments. Dashboards can track AI usage metrics such as active models, retraining frequency, or governance review completion, and feed this data into compliance dashboards for real-time visibility. Audit log retention must be configured to meet SOC 2 evidence standards, preserving complete historical context. When properly implemented, automation doesn't replace governance, it strengthens it through consistency and verifiable audit trails. Metrics and key risk indicators, KRIs, bring quantifiable oversight to AI risk management. Examples include the number of AI systems formally reviewed under governance programs, the frequency of drift or bias incidents, compliance scores for model documentation completeness, and the average time to remediate post-assessment issues. Tracking these indicators over time helps organizations measure both maturity and responsiveness. For SOC 2, these metrics act as operational evidence that AI-related controls function continuously and are monitored systematically. They provide auditors with a data-driven view of control effectiveness and a clear signal that AI risks are managed with the same rigor as traditional systems. Evidence expectations for AI assurance mirror those for any in-scope technology, but with expanded documentation. Data Protection Impact Assessments, DPIs, model validation logs, and access control reports form the core evidence package. Version control records show traceability from model creation to deployment, while governance committee minutes and vendor attestations demonstrate oversight and accountability. Bias testing results, drift monitoring exports, and incident logs provide proof that controls operate continuously. Together, these artifacts illustrate an organization's AI assurance lifecycle, designed, implemented, monitored, and improved, fulfilling SOC 2's requirement for verifiable, repeatable processes. As organizations mature, AI governance progresses through defined stages. Early adopters focus on ad hoc control adoption, basic documentation, and reactive reviews. Over time, this evolves into standardized validation and centralized AI governance committees. Mature programs embed automated compliance monitoring and periodic risk scoring. At full maturity, the AI lifecycle becomes transparent, auditable, and self-regulating, guided by predictive analytics and continuous assurance mechanisms. This maturity curve mirrors the SOC 2 philosophy, moving from reactive oversight to proactive, data-driven assurance across every dimension of technology, including AI and machine learning. Continuous improvement ensures that AI governance remains current and adaptive. Lessons from model incidents, regulatory updates, or ethical audits should feed directly into policy revisions. Training programs for engineers, data scientists, and compliance officers reinforce awareness of AI ethics, privacy, and accountability. Improvements should be mapped to measurable outcomes, such as reduced bias rates or faster remediation cycles. Publishing AI assurance summaries, similar to SOC 2 reports, demonstrates transparency to customers and partners. Continuous improvement transforms AI compliance from static control maintenance into an evolving discipline, one that reflects the organization's dedication to responsible innovation. In conclusion, governing generative AI and machine learning systems under SOC 2 is about embedding transparency and accountability into every phase of the AI lifecycle. From data handling and model validation to drift monitoring and regulatory mapping, each control reinforces trust in both the technology and the organization behind it. Automation and evidence generation ensure that compliance keeps pace with innovation, while governance and ethics anchor progress in accountability. By aligning AI operations with SOC 2 and privacy frameworks, organizations not only secure compliance but also strengthen customer trust, demonstrating that responsible AI is not merely a requirement but a core element of sustainable, trustworthy service delivery in the digital era.